Okay, so we will be discussing May-June 2023 statistic 1 paper 5.1 in this video. Okay, so we'll start with question number 1. Right, so they give us a summary of 50 values. So I think you should know that the n here is 50. And then we are having the summation of x minus q and also the summation of x minus q squared, where the q is a constant. So first of all, they want us to find the standard deviation of these values of x. Okay, so they want us to find the standard deviation. Right, so when we're having this data, right? Okay, so it is basically using the coding method where the general formula for coding method standard deviation will be, maybe I put it in this way. So the general formula is actually standard deviation equals to the summation of x minus q squared divided by n, then minus the summation of x minus q divided by n, and we square this whole fraction. And for standard deviation, of course, we need to take a square root. Alright, so this is a general formula to find out the standard deviation by having all this data, alright, all this value. Okay, so please take note that this formula is not provided in the formula booklet, so please make sure that you can remember it, right? Okay, so we straight away apply the formula that we have here, apply all the value that we have here. So for this standard deviation, basically, if I substitute the value into the equation, I'm having 14235 divided by 50. Okay, so we're having 50 values. Then minus the summation of x minus q. So it will be 700 divided by 50, and I want to square it. Then take square root. Okay, by just pressing calculator, if you didn't do any careless mistake, then you will get this long answer here. And of course, we have to cut it short into 3 significant figure answer. So the final answer will be 9.42, correct to 3 significant figure. Okay, so we just substitute the question into the formula. And this question is very straightforward, right? But you need to remember the formula itself, right? Because this is not provided in the formula booklet. Right, so let's proceed to part number B. Okay, so for part B, they give us another extra value here where summation of x equals to 2865, and they want us to find the q. Okay, when we're having the summation of x, right? And also with all the data here, all the values here, basically I can try to compare the mean that we can calculate from these two formulas. So there are two formulas for mean in general. The first one will be summation of x divided by n. And the second one will be summation of x equals to, the mean will be equals to summation of x minus q divided by n, then plus q. Okay, so please take note that the mean that we find out from these two formulas should be the same. Therefore, by using these two formulas and equate them, right, I can try to find out the value of q here. Okay, so first I want to apply summation of x divided by n. Summation of x is 2865 divided by n, which is 50, equals to the mean from this formula. So the mean from this formula will be summation of x minus q. Where is summation of x minus q? This one, 700, right? So I put in 700, then divided by n, so divided by 50, plus q. The value of q I don't know, so I just leave it as q. So from here, you can see very easily that we'll get the q after we move all the number to the other side. So we can see that q is actually 43.3. Okay, so this is how we solve question number 1. Okay, so question number 2. Find the number of ways in which a committee of 6 people can be chosen. So highlight the keyword chosen. That means this is about combination. So later when you solve the question, right, you should consider the combination, which is something like NCR, right? So the chosen from 6 men and 8 women, if it must include 3 men and 3 women, right? So you want to select 3 men from 6 men and also 3 women from 8. Therefore, to form this committee, the number of ways will be 6 men. I want to choose 3 of them to be in the committee, and also 8 women. I want to choose 3 of them to be in the committee. So it will be 6C3 multiplied with 8C3. And the answer should be 1120. So just in case if you want to ask why there's a multiply here but not a plus. Okay, so to make this committee complete, I need to have both men and women. So to make them complete, right, I have to multiply them to make a committee complete. If we have another case for other committee, then it should be plus. Right, so for this case, it will be multiply because of I want to make the committee complete by multiplying the men and also the women together. Okay, so this is what we have for part A. Then proceed to part number 2. For part B, okay, so we want to form another committee. There are 6 people also to be chosen, so highlight the keyword chosen again. This tells you that this is a combination question again. Right, so we are having 6 men and 8 women. 3 of the 6 men are brothers. So there are 3 of the 6 men are brothers. Okay, then again, they want you to find the number of ways in which the committee can be chosen again. If there are no restrictions on the number of men and women, so that means the gender is not important here. Okay, but it must include no more than 2 of the brothers. Okay, so when the question mentioned that no more than 2 of the brothers, you're having 3 brothers in total, right? So that means when you want to form the committee, right, there are a few possible cases that you can consider. The first case is you are having 0 brothers. Okay, so 0 brothers in the committee. Then 1 brother in the committee, 1 of the brothers in the committee, and also 2 of the brothers in the committee. Okay, so these are the 3 possible cases that you want to consider lah. Alright, so to me, right, because I feel that I want to calculate these 3 cases separately, it is longer. So what I want to do is, I try to find out the cases where I will find 3. All the 3 brothers are in the committee, and I take total minus this case. Then to me, I think it will be slightly shorter lah. Right? So there are 2 methods to solve it for this question. So the first one is you solve the question by considering these 3 possible results. Okay, the 3 possible cases here. Or you can consider the case where you include all the 3 brothers in the committee, then you take total minus the 3 brothers. Alright, so first of all, I will calculate the total of combination first, total ways. So the total ways without restriction, that means without considering any restriction mentioned in the question, what is the possible ways, okay, that I have to form the committee. So in total, I'm having 6 plus 8, right? So 6 plus 8, total I'm having 14 of them, and I want to form a committee with 6 people, right? So the total way will be 14C6. Okay, then I will get 3003. Alright, so I settled the total part here. Now I want to consider all the 3 brothers are in the committee. So all 3 brothers in the committee. Okay, so it can be, so now we have to consider the cases. We want to form a committee with 6 members, right? And then the 3 brothers are already in the committee. Therefore, I only have 3 empty space left, right, for to form the committee, right? So I still need to choose 3 person to be to fill in, right, to fill in these 3 empty slot here. Okay, so when I already have 3 brothers in the committee, that means originally total I'm having 14 people. When I take out the 3, so the total number of people become 11, correct or not? Alright, so from this 11 person who are not the brothers, okay, I want to choose 3 of them to be placed in the committee here. Therefore, it will be 11C3. Okay, then all the 3 brothers here are already in the committee, so if you want, you can write out multiply with 3C3 if you want. Okay, right, so 11C3 is from the remaining person to fill in these 3 empty slot here in the committee. Multiply with all the 3 brothers are in the committee. So you have 1120. Okay, for the case where all the 3 brothers are in the committee. So now to calculate the number of permutation or number of selection. So the number of selection will be, you have to take the total minus the 3 brothers one. Okay, so from here I will get 2838. Right, so this is how we answer the question. Okay, all right, so just in case some of you who wish to use the 3 different cases here to solve the question, right, then I can show you here also. Right, so maybe I will show it in different color. So I put it like this. Yeah. Okay, so now if you want to consider all the possible cases for not more than 2 of the brothers are in the committee, so you have to consider these 3. The first case is no brother in the committee. So case number 1, 0 brother. When you're having 0 brother in the committee, right, that means all the 6 slots are still empty, okay, to be filled up. All right. Since the 3 brothers, I want to ensure that the 3 brothers are not in the committee. Therefore, I have to exclude them from the total number being chosen. Therefore, my total person can be choose is 11. So from this 11 person, I already exclude the 3 brother here. Okay. So from the 11 person, I want to choose 6 of them to form the committee. Therefore, right, the very first case is 11C6. So I'm having case number 1, which is 11C and then 6. 11 person, I want to choose 6 of them to be placed into the committee. I'm having 462 as a first case. All right, then I consider second case where I put 1 brother only in the committee. So 1, 2, 3, 4, 5, 6. Okay, to be more accurate, okay, maybe for case number 1, I write 11C6, then multiply with 3C0. Because from the 3 brothers here, I want to select only 0 of them to be placed in the committee. Therefore, you're having 462. Okay, so case number 2. For case number 2, I want to place one of the brothers in the committee. Then the rest are not the brothers. Okay, so again, I'm having 3 brothers and also total 11 of the other member. Right, so from the 11 member, I want to choose 5 of them to be placed in the committee. And also from the brothers, I want to choose 1 of them from out of the 3. Okay, so for this case, I'm having 11C5 multiplied with 3C1. So what I get is 1386. So this is the second case. And now we want to consider for the third case. For the third case, I fix 2 brothers in the committee. 1, 2, 3, 4, 5, 6. Okay, 2 brothers are in the committee. So again, I'm having 3 brothers and also 11 other person. Okay, so from the other person, 11, I want to choose 4 of them to be placed in the empty slot here. So 11C4, then multiply with. From the 3 brothers, I want to choose 2 of them and place. So I'm having 3C2. Okay, so you can try to take 11C4 multiply with 3C2. By right, you should get 990. Okay, so after you consider all the 3 cases already, then what you do is you try to total all the possible cases together. So I'm having 462, then plus 1386 plus 990. So you can get the same answer also with the method that I showed you just now, which is 2838. Right, so these are the 2 possible ways that you can find out the number of selection. Okay, so to me personally, I feel that this one is slightly shorter and this one is slightly longer because you need to consider 3 different cases. All right, so this is how we answer question number. Okay, so we come to question number 3. They want us to find the number of different arrangement. So highlight the keyword arrangement. Again, the word arrangement tells you that this is a permutation question where your solution later, right, will actually involve maybe the factorial or the term like NPR. Okay, so we are having 8 letters here of this word cocoon, okay? And then before we arrange all the letters, right, we try to have a look how many identical letters that we have. So we are having actually 2C, and then we are having 3O from the word, 1N, 1E, and also 1D. Okay, so for this question, it wants to find different arrangement for these 8 letters only. So we are having 8 letters in total. Therefore, to arrange the 8 letters, we are having 8 factorial. But from these 8 letters here, right, we are actually aware that we are having the identical letter C and also the identical letter O. Therefore, I have to divide them by 2 factorial and also the 3 factorial. because of 2C and 3O lah. Right. So for this case, the number of permutation or the number of arrangement will be 3,360. Okay, so this is how we get the answer for part 3A, question 3A. Okay, then we proceed further. Now they want us to find the number of different arrangement again, highlight the word arrangement, of the 8 letters in this word, in which the first letter is O. So they now actually try to make some restriction here. The first letter is O and also the last letter is N. Okay, so if first letter is O, I put it as O, then I'm having 6 letters in between, right? Then followed by the last letter N. Okay, so if now, before we arrange it, right, the O is fixed and also the N is fixed. That means I'm not going to touch them anymore. I'm not going to arrange these two particular letters anymore. I want to focus only on the arrangement of the 6 letters in between. Okay, so what are the letters that we still have for these 6 letters here? One O already been placed in the first letter, right? So I left only 2O here. And then one N is already placed here, so I'm having 2O, 2C, 1E, and also 1D to be placed for these 6 letters. Alright, so for this question, it is like, now you want to arrange the only 6 letters in between. So you're not going to consider the first letter and the last letter anymore. Right, so for the 6 letters here, so to arrange the 6 letter, I'm having 6 factorial, right? And then from these 6 letters, we actually have the identical letter again, right? Okay, so what are the identical letter here? I'm still having 2O, therefore I have to divide it by 2 factorial. Then the 2C, I also have to divide it by 2 factorial. Okay, so for this case, I'm having 180 arrangement for this particular restriction. Okay, so this is how we arrange it. And now we proceed to part C. Okay, so for part number C, okay, they want us to find the probability, the word probability. Then for a randomly chosen arrangement again, for this word again, all right, has all the 3 O's together, given that the 2 C's are next to each other. Okay, so for this question, right, they want us to find the probability, and please highlight the keyword given that. So this particular word tells us that this is a conditional probability. Okay, so conditional probability. Okay, so for conditional probability, right, given that something already known has been already happened, so this is maybe event A, and then has all the 3 O's together, maybe this is event B. So find the probability that B happened given that A happened. So for this question, right, basically they want us to find out the probability for B stroke A. Okay, so before we find out the probability, we try to write out the definition for the conditional probability first. So we are actually looking for B intersect with A, then divided by A. Okay, so before we found the probability, maybe we focus on the probability of A first. So the event A is 2C are next to each other. So first, I let A equals to 2C are next to each other. Okay, so what is the number of ways that we have 2C which is next to each other, right? When we are trying to solve the case where 2C are next to each other, right? What we do is we try to tie the 2C together become one unit. So I assume that these 2C are in one unit. So the 2C are next to each other. Then the rest of the letter, I just arrange them normally. So if I treat the 2C into one group, right? So I'm having 7 items here. 1, 2, 3, 4, 5, 6, 7. Therefore, when I want to arrange these 7 items, I'm having 7 factorial. But from these 7 items here, I'm having 3 identical O. So I have to divide it by 3 factorial. So the number of way for event A will be 840. Okay, all right. So this is the A, the number of waves that A happen. Then to change it become the probability, right? Later I need to divide it by the total number without restriction. So the total number without restriction, we already get it just now in part 1, which is 3360. Okay, so to get a probability, you just need to take the event A happen divided by the total without restriction, divided by 3360. Okay, so I come back to question number C here. So 840, when I want to convert it into the probability, I will divide it by 3360 later lah. Okay, then now I focus on event number B. So event number B has all the 3 O together. But according to the definition for the conditional probability, right? Okay, what we are interested is this one, B intersect with A. That means I want to know B intersect with A or A intersect with B, which means that I want to know all the 3 O are together. At the same time also, the 2 C are next to each other. Okay, so we are interested in this event, A intersect with B, so that I can calculate the conditional probability later. Alright, so when I have B intersect with A, so just look at this one, all the 3 O together. So if I want to have 3 O together, I will bundle them become one item also. Intersect with the 2 C are next to each other, that means the 2 C must be together as well, because these two must be happen at the same time, right? And then the rest of the letter NED can be arranged freely. Okay, so when I want to arrange the combination like this, right? I'm having how many items here? So 1, 2, 3, 4, 5. I'm having 5 items here. Therefore, I need to divide it. I need to arrange 5 items. Therefore, it is 5 factorial. And out of the 5 items here, there's no identical letter because the 3O here, I make it as one unit. So it is not considered as identical letter. Okay. Then the 2C here, I also consider it as one unit. So between the 5 items here, there's no identical. Therefore, the answer is straightforward, which is 5 factorial for A intersect B, and therefore I'm having 120. Okay, then now I want to group everything now together to find out the conditional probability. Again, keyword is given that. Therefore, I want to find the conditional probability for B given that A happen. So the general formula is this one. Alright. Okay, so when I write out in detail, it should be something like this. So B, all the 3 O's together. Okay, given that the 2C next to each other. Okay, so the formula will be 3O together intersect with 2C next to each other, which is this one, 120, divided by the total number without restriction in part number 1 is 3360, divided by, so this 120 over 3360 is probability of B intersect A on top. Then now, how about the probability of A at the bottom? So the probability of A is this one, 840 divided by 3360 as well. Okay, so from here you try to simplify the answer, and by right you should get a fraction which is 1 over 7. Okay, so how I know that this is a conditional probability question? Again, the keyword is given that. Therefore, I have to apply the formula for the conditional probability, and this is what we get. Alright, okay, so this is how we answer question number 3. Okay, so let's discuss question number 4. There's a mathematical puzzle is given to a large number of students, and then the time taken to complete the puzzle are normally distributed. So highlight the keyword normally distributed. So this keyword tells us that later when you want to find out any probability, we actually to standardize the variable, become Z. Okay, and then the mean is 14.6 and also the standard deviation is 5.2. Right, so from here I already know that my X is normally distributed with 14.6 and also 5.2 square. Okay, in a random sample of 250 of the students, How many of you will expect to have more than more than 20 minutes to complete the puzzle? So before we can find the expected value from 250 students, right? So the very first step is we need to find out the probability of X, the number of time taken is greater than 20 minutes first. After you get the probability, only we multiply with 250 to get the expected value. Okay, so how are we going to find out the probability for X greater than 20? So again, because the keyword normally distributed, so we know that before we can find out the probability, we have to standardize it. We have to change the X become Z, and then we are taking 20 minus the mean divided by standard deviation. So divided by the standard deviation is 5.2 for this case. Okay, so press calculator, try to get the value for the Z correct to 3 decimal places because we want to find out up to the maximum decimal place in the normal distribution table. It should be 3 decimal place, alright? So 1.038. To find out the probability of Z greater than 1.038, if you draw a simple diagram for normal distribution, this is 1.038 and the area that I'm interested in is this part. Okay, but when you want to find the probability from the table, right, the answer that we get is actually the smaller than one, Z smaller than 1.038. So to get the red color area, I have to take 1 minus the green color area that I find out from the table, right? Okay, so remember 1.038, so I go to the normal distribution table, looking for the value of Z on the left hand side here. This is the Z, right? Can you see that? We are looking for 1.038. So 1.03, okay, we get this value here, and then 8 at the back. So for 8 at the back, right, we should add 19 to the last 2 digits of 8485. Add 19 to the last digit of 8485, and what do we get? So we'll get 8504. So I have to take 1 minus 0.8504. Okay, and from here I'll get a value 0.1496. This is a probability that X greater than 20 minutes. Okay, but for this question, they're asking for the expected number from 250 students. That means to get the expected value, I have to take 250 multiply with 0.1496. So by right, we will get the value, which is 37.4. Since we are talking about the number of students, right? So we will actually keep our final answer as a positive integer. So you can keep your answer become 37. Okay, so the answer will be 37. Or the marking scheme actually accept also the value of 38. Alright, so 38 also acceptable according to the marking scheme. But you have to put your final answer in a positive integer because of we are talking about the expected number of students. Right, so both answer will be accepted here. You can write either 37 or either 38. Okay, so this is how we solve part A. And now let's proceed to part B. Okay, so for part B, now we are having the students given the second puzzle to complete second puzzle. So their time in minutes are again normally distributed. One more time. With the mean value, I don't know. They just give us the symbol mu, and standard deviation also I don't know. They just give us a symbol sigma. Then they say it is found that 20% of the students have time less than 14.5 minutes. So for this particular sentence, right, 20% of the students have time less than 45 minutes. If I try to convert it into a symbol form, it will be the probability of X less than, so smaller than 14.5. And it is 20%. So 20%, if I convert it into a probability, it will be 0.20. So this particular sentence, okay, in red color bracket, I can convert it into a symbol in this way. Okay, alright, then now I know that the time taken is actually normally distributed. Therefore, to calculate the probability for the X, I have to standardize it become Z. Then to standardize it become Z, I'm having 14.5 minus the mean. I don't know the value of mean, right? So I just write it like this, divided by standard deviation. okay, then equals to 0.20. And now I'm interested to find the value of z. What is the value of z? So that z smaller than this particular value, it is equals to 0.20. Okay, so basically it's like this. When I have a basic graph for this one, okay, they said smaller than. So that means on my z should be a negative value. Smaller than means that I should shade the area on the left hand side, and it should be a small area because 0.20 is less than half, right? So this is 0.20. Okay, then to find out the value of z, it should be a negative value one because you can see that it's on the below the center line. The center here is a 0. Okay, so below the 0 means should be a negative value for the z. Okay, to get the value of z, right, I have to refer to the normal distribution table again. But to refer the value 0.20, you will see that in our table, right? 0.20 is actually a probability lah. So you can see that all the center value here are probability. All these values are probability. And you realize that there's no 0.20. All the values given are more than 0.5. Therefore, to find out the correct answer, right, I actually have to find out the, the paired probability lah. So this is 0.20. The paired probability will be 0.8. So to find the value of z from the normal distribution table, I should look for 0.8 from the normal distribution table. And this 0.8 is a probability. Therefore, when I want to look for the value, I'm looking for the 0.8 from this part. So there are many values here, right? I find a value closest to 0.8 but less than 0.8. So you can see this is the one. 0.7995 is smaller than 0.8 but closer to 0.8, because if you look at the next value, it is already more than that. All right, so I want to choose a number closest but smaller than 0.8. Okay, so when I look for 0.7995, if I read the value of z from here, I'm getting 0.8, then 4. Okay, then to make this number become 0.8, I need to add the 5 at the last digit, right? So I'm looking for the 5 at the same row. Okay, that means if I add this 5 in the last digit, I'll get 0.8. So when I add the 5, right, the number followed at the back is 2. So that means if I read the value of z straight away from the table, I'm having 0.842. Okay, so here, this value of z should be 0.842, but from the diagram, you can see that z is at negative part. Therefore, z should be equals to negative 0.842. And what is the value of z? This is actually my value of z, the highlighted part here. So I'll equate the z equals to negative 0.842. So from here, I actually will form the first equation in terms of mu and sigma, where it should be 14.5 and then plus 0.842 sigma. And this is my first equation. Okay, so with only one equation, it is not enough for me to find the mean and also the standard deviation. Therefore, I want to form another equation. How to form another equation? So we continue to read the question again. Now they said 67% of the students have time greater than 18.5 minutes. Again, when they say the time is greater than 18.5, so when I write, it should be x greater than 18.5 equals to what is the probability? They said 67%. If I convert into probability, it will be 0.67. Okay, so again, from this purple color bracket here, I can actually write out the sentence into a symbol like this, the equation like this. Okay, and again, so we repeat the process just now. X is normally distributed, therefore I have to standardize it become z. Then I take the value of x minus the mean divided by standard deviation, and that equals to 0.67. Okay, after that, to decide the value of z, it will be good if I can try to visualize first. Okay, 0.67 is a large area lah, so it should be more than the half the area. Therefore, if I want to sketch the diagram, I know that my Z will be here and Z greater than. So greater than means that I want to shade the area on the right of the Z. Okay, and this particular area here is 0.67. Okay, alright, so if I look at the diagram here, I know that Z is below the 0 again, therefore the Z should be a negative value. And this area is a large area at 0.67, therefore I can straight away look for the answer. Okay, so let's have a look here. 0.67, which is a value smaller than 0.67 but closest to it. So for this question, right, maybe you can see very clearly that I already found the 0.67, which is this one. Just nice. Okay, so if I try to read the value of Z, it should be 0.44. Okay, so my value of Z should be 0.44. Go back to the question. Okay, so the Z should be 0.44. But again, from the diagram, you can see that Z is below the x-axis. Below the 0. It should be a negative value. So we just now we get 0.44, right? I should put it as negative 0.44 here. And then again, what's the value of Z? Is this one in our symbol, in our equation. So 18.5 minus the mean divided by standard deviation, then you get negative 0.44. Again, from this step, you can rephrase everything again. Then you will have the equation in terms of mu and also sigma again. If I didn't do any careless mistake, it should be something like this. And this will be my equation number 2. Okay, so you have two equations in terms of mu and also the sigma. Therefore, you can solve them simultaneously to get the value. Okay, so to get the answer for the mu and also sigma. Okay, so I will let equation number 1 equals to equation number 2. Okay, so I'm having 14.5 equals to 18.5. Okay, so I try to solve the equation here. By right, I should get sigma equals to 2000 over 201. And of course, you can change it become 3 significant figure where it should be 9.95. Okay, then after that, please use the fraction 2000 over 201, substitute it into either equation number 1 or number 2 to get the mu. So from here, by right, the mu that you get should be a long number, 22.87810945. I substitute the whole fraction inside the equation. And I want to simplify my mu here, which is 22.9, correct to 3 significant figure. Okay, so this is how I solve the question and get the mu and also sigma. Okay, so now we are at question number 5. We are given a table with the population of 150 village in UK, and then to the nearest 100. Okay, they are talking about the population in UK. Then they summarize everything here in the table. So first of all, they want us to draw a histogram to represent the information. Okay, before you draw the histogram, right, the very first thing we need to double check is we have to make sure that we have to check whether all the width for the bar here are the same or not. All right, and before we start, let's have a look at whether do we have the class boundaries or not. So you can check the upper limit for the first class and also the lower limit for the second class. So you can see that one value ends with 800, another value starts with 900. Therefore, you can see there's a gap between them. But when we want to sketch a histogram, there shouldn't be any gap between them. Therefore, for this value, I need to add 50. And then for this value, I need to minus 50 so that they share a common value, which is 850. So that means after I adjust them become 850, then there's no gap between all the classes. All right. So before we can start calculating the class width, or maybe before we can sketch a histogram, this is the first thing that usually we want to check. All right. So from here, you can try to minus 50 for every lower limit for the classes. and also plus 50 for every single classes for adjustment. Right, so to make the calculation and drawing easier later, I will want to show the step maybe here. Okay, so I try to copy the question here. So this is what we have. Okay, so first of all, I want to have class boundaries, right? Okay, so for the class boundary, like what I mentioned earlier just now, okay, I want to take the lower limit minus 50. So first class, I'm having 50. The upper limit, I will want to add 50 for every single class. So 800 plus 50, I got 850. Same thing happened for the second class. I'm having 850 and 1250. For the third class is 1250 become 2050. Fourth class is 2050 become 3200. And the last class will be, 3250 because I add 50, right? So 3250. And after that, what else do I have for the last class? I'm having 3250 become to 4850. Okay, after that, we are talking about, after you find out the class boundaries, right? Basically, we should check about the width for the class. Okay, so to take the width, to calculate the width, I should take 850 minus 50. I should take the upper class boundary minus the lower class boundary. We cannot take class limit minus the class limit. Okay, because there's a gap. So when we want to calculate any width for the classes, we have to ensure that we already have the class boundaries in our data. Right, so 850 minus 50, I have 800. 1250 minus 850, I got 400. Okay, 2050 minus this one, I have 800 also. Then the same thing applies for the other cases. So I'm having 1200, and this one will be 1600. Okay, so this is my width. And after that, after I get the width, you can see that all the width, they are not having the same value. Not all the width are having the same value. Therefore, for this histogram that you want to sketch, it is an unequal width histogram. Okay, because you can see very clearly that our interval, right, the class boundary are not having the equal width. So we are going to sketch an unequal width histogram. To sketch an unequal width histogram, right, we need to know that the y-axis is actually the frequency density. And then this is the x, right? So frequency density is having the formula. Okay, so maybe I write it out here. Frequency density. The formula will be equals to frequency divided by class width. Okay, so before I sketch the diagram, I need to get the frequency density first. Okay, so for frequency density, I need to take frequency. For the first class is 8 divided by 800. So 8 divided by 800, I'm having 0.01. Okay, so 12 divided by 400, therefore I get 0.03. So we try to complete every single class to get the frequency density. Okay, so after we get the frequency density, please make sure that when you calculate the frequency density, you try to show it up in your solution or calculation. Okay, so after I get the frequency density already, then we can start sketching the histogram, right? So my y-axis will be this one, which is the frequency density. My x-axis will be the class boundary here. So the width of the bar, right, I need to refer to all the value for class boundaries. All right. Okay, so let's start. Okay, so to sketch the histogram, okay, maybe I adjust it slightly. Okay, I want to put everything inside this curve, inside this graph paper, sorry. Okay, so my lowest value for x-axis will be 50. The highest value will be 4850. So what I'm going to do now is I will try to sketch the x-axis here. Okay, so I think it is not thick enough, right? So maybe we can make it thicker. Okay, so when I try to label, I will start to label it with 50. You can see that all my limit here, right? The class boundary, they end with something something 50, something something 50. So to make my calculation and draw the graph process easier, I will start the value with 50. So that means between 0 until 50, right? I might want to draw a arrow. Okay, wait. So this is my y-axis. Okay, then I draw maybe a zigzag sign or whatsoever sign here. Okay, then we'll start with 50. And then for every 2 cm, okay, I will want to make it as 1000 units. So this one is 1050. This one is 2050. Then 3050, 4050, and also 5050. So I think the x-axis here can fit in everything, right? So I will write as population at my x-axis here. Okay, then after that, for my y-axis, the lowest value is 0.01 and the highest value is 0.0625. So I think for the frequency density here, I can make every 2 unit at 0.01. So I'm having 0.02 here, then 0.03, 0.04, and so on. Okay, so this one is 0.07. And then don't forget to label the y-axis, which is frequency density. Okay, so we can start sketching the diagram now, the histogram now. The first class is from 50 to 850, and then the height should be 0.01. So from 50 to 850, right, should be somewhere here. Start from 50, okay. So 850 should be somewhere here lah. Okay, maybe I can make my pens look thicker. Wait, can I adjust it slightly? Okay, so this is my first class from 50 until 850, and then the height is 0.01. Then the second class is 850 to 1250. So 1250 is 2 boxes after the 1020, 1050. Then the height is 0.03. So 0.03 means somewhere here. Okay, so this is my 1250. And this is my second class. The third class is from 1250 to 2050, and the height is 0.0625. So 0.0625 should be somewhere here, half of the second box. Okay, then until 2050, so means somewhere here. Like. Okay, so you can try to sketch it by using your own ratio and the graph paper. Okay. Alright, then after that, for the fourth class is from 2050 until 3250, and the height is 0.04. So 0.04 until 3250. So 3250 means 2 boxes after 3050. So this is what I have. Okay, and after that, the last one is 3250 until 4850. And the height is 0.02. So 4850 will be 2 boxes before the 5050. So this is what I should have. Okay, so basically our graph should look something like this, our histogram. And if you try to observe, you will see that they are having unequal width. Okay, so this is how we set up the question to draw the histogram with unequal width. Alright, okay, so just take note that please make sure you try to show your solution with all the value of frequency density that you calculate. Right, so that you can get a meta mark from here. Okay, so this is what we have for part number A. Let's have a look for part B. Okay, so for part B, they want you to write down the class interval which contains the median for this information. Alright, so highlight the word median. We want to get the value for median. How can we get the value for median? But they actually not asking for the median value. They're asking for the class interval only. The class interval which contains the median for this information. Okay, so before we can get the median, right, we have to go back to our data. To get the median, basically I need to have the cumulative frequency value, the cumulative frequency. All right, so the first value is 8. The second value will be 8 plus 12. So 8 plus 12, we will get a 20. Then plus the next frequency, which is plus 50. So I'm having 70. Plus the next frequency again, I will have 118. And then plus 32, I will have 150. Okay, so to get the median, basically it is the value that shows a half of your total frequency. So where is the value that is half of my total frequency? So if I take 150 divided by 2, I want to check where's my 75 value in the data. Okay, so you can observe from the frequency density here, from the cumulative frequency here. So the first class accumulate from the first value until value number 8. And after that, the second class accumulate until the value 20, the 20th value. Then the third class, the highest frequency that we accumulate is 70. So 75 will be somewhere here. Okay, so 75 will be somewhere here. Therefore, our median interval will be 2100 until 3200. Okay, so this is how we decide. So we can write as 2100 until 3200. Okay, then for part number C, they want us to find the greatest possible value of the interquartile range. So for interquartile range, I need Q1 and also I need Q3. So again, first of all, I need to find out what is the class interval that contain Q1 and what is the class interval that contain Q3. Okay, so we go back to our cumulative frequency curve here, the cumulative frequency data. Right, so for Q1 is actually the first 25% of the data. So that means I take 150 divided by 4. If you take 150 divided by 4, then you get the 37.5. That means my first quartile, right, should be the 37.5 data in this set of data here. Okay, so again, I have a look for the cumulative frequency. First class, accumulate until the frequency 8. Second class, accumulate until the frequency 20. Then you can see that 37.5 should be under this class. So the Q1 class will be 1300 to 2000. Okay, so I will write it here first. So my Q1 class is 1300 to 2000. Okay, then after that, we go back to our Q3. So for Q3, I need to take 3 over 4 multiply with 150. So if I take 3 over 4 multiply with 150, I will get 112.5. So again, I will ask myself, where is my 112.5 data? Okay, so you can see that this class accumulate until 118, the frequency. Therefore, 112.5 is inside this class. My Q3 will be under this class as well. So 2100 to 3200. Okay, so my Q3 here will be 2100 to 3200. Okay, and now they are asking for the greatest possible value of the interquartile range. So to get the interquartile range, right, I have to take Q3 minus Q1. And please take note for this class interval, this is class interval, right? When you want to calculate the class, the interquartile range and everything, we have to consider the value of class boundary. So for this one, it is actually 1250 to 2050. Okay, then for this one, it is actually 2050 to 3250. All right, so what is the value that I can get so that when I take Q3 minus Q1, I will get the largest value. So you can see that you try to do some simple analysis here, right? So my Q1 must be the smallest, right? If I have the Q1, which is the smallest value, and the Q3 is the largest value, when I take largest value minus the smaller value, I will get the answer with the greatest possible answer, right? Therefore, the largest Q3 will be 3250. Okay, and then the smallest Q1 will be 1250. So when I minus them, I will have 2000, which means that the 2000 will be the greatest possible interquartile range that I can get from this set of data. Alright, but of course, all these are just estimation because we actually don't know what's the original data that we have. We only have the class interval. Okay, and then just a reminder, before you want to calculate the interquartile range, don't forget to use the value of class boundary. Alright, so this is how we solve question number 5. Okay, so we are now at question number 6. We have four-sided dice. Alright, we are having 4 dice. Okay, and then label 1, 2, 3, 4. And then because of the word fair, we know that the probability of getting each of the number here should be equal, which is 1 over 4. Right? He throws all the 4 dice at the same time. Okay, the random variable x denotes the number of 2 that obtained. So show that the number of 2 obtained equals to 3 equals to this probability. Okay, so for this question, maybe before we start to calculating the probability, right? Maybe you can try to observe and see what kind of method can we use, and then is this question belongs to any distribution or not. We are having 4 dice, so the total number of dice is always fixed. Every time he will throw 4 dice is fixed, right? And then since all the probability of getting the number here are also fixed, so that means to get the probability of 1 over 2, get the number of 2, it is 1 over 4. The rest also 1 over 4. Okay, and then the random variable x denotes the number of 2 that obtained from the 4 dices when he throw at the same time. Okay, so from here, basically, we can say x belongs to binomial distribution because we are having the fixed number of total trial, which is a 4. And then if I make the probability, the variable that we are interested is the number of 2 obtained, the probability of getting the 2 is also the same for each dice, right? Which is actually 1 over 4. So basically, this is a binomial distribution, if you can observe and get the idea, right? And if I already identify that x belongs to binomial distribution, then when you want to calculate the probability for x equals to 3, it will be very straightforward, where you will have 4c3, okay, then 1 over 4 power 3, then 3 over 4 power 1. This is the general formula for the binomial distribution when you want to calculate the probability. Okay, then very directly you can get the answer, which is 3 over 64. Alright, okay, so if let's say you're not able to observe and get the idea that this is a binomial distribution, then the other method is you can list out the probability one by one, but of course you need to try to consider the number of arrangement involved. Okay, so as an example, if I want to calculate the probability for x equals to 3, I'm having 4 dice in total, right? So that means out of the 4 dice, I need to have 3, number 2. Okay, let's say the first dice I get is number 2, which is 1 over 4. The second dice that I get is also 1 over 2, is also 1 over 4, which is 2. Then the third dice I also get a 2, which is 1 over 4. And then the fourth dice that I get is not a 2 anymore because I already have 3 2s here, right? So I will make it as 3 over 4. 3 over 4 means that it can be belongs to any other number. So this one, first dice is a 2. Second dice is a 2. Third dice is a 2. And the fourth dice can be either 1, 3, or 4. So this is a probability if I arrange or if I assume that my dice result is 2, 2, 2, and then non-2. Okay, but of course, when you calculate the probability, right, it is not always that the first die always must be a 2, the second one must be a 2, the third one must be a 2. You can see the changing, okay? I might have the first one is a 2, but the second one is not a 2, then third and fourth are the 2. So you need to consider the arrangement for these 4 dices here. Okay, I'm having 3 2 and also 1 non-2, right? So if I list out like this, for first case, okay, so for the first case, I'm having 2 2 2 and then non-2. I might also have the second case where I'm having 2 2 non-2 and 2. The third one can be 2 non-2, 2 and 2, and the fourth one can be non-2, 2, 2, 2. So you can see that totally I'm having 4 different arrangement here. Therefore, I can write it out as times 4. Okay, or maybe some students they are saying that, oh, I'm having 4 items here. So what they make is they can make it as 4 factorial, then divided by the 3 identical to, so divided by 3 factorial. So 4 factorial divided by 3 factorial, it is also a 4. Alright, so you can do it in this way, and of course your probability is equals to 3 over 64 as well. Okay, so basically these are the two methods that you can try out. Alright, so if you are the students who are able to identify that this question belongs to binomial distribution, then it will be very straightforward for you. You can straight away apply the binomial formula. But if you cannot identify that this is a binomial distribution, since it is not so obvious, so you can try to list out the probability dice by dice. And of course, you have to consider the arrangement for all the 4 dices. Alright, so this is what we have for the probability of x equals to 3. Okay, so for this first part here, generally you have to make sure that the method that you are using is the correct method so that you can use the same idea or same concept in the next few coming part in the same question. Alright, okay, so this is how we solve part A. And now let's proceed to part number 2, part B. They want us to complete the following distribution table for the x. Okay, so for just now, we already calculate the probability for x equals to 3. Alright, so if you are the one who already observed that, already know that it is a binomial distribution, then to calculate the probability of x equals to 1, it will be very straightforward as well. Okay, so I rewrite it again. X is binomial distributed. The total trial is 4. The probability of getting a 2 is a 1 over 4. Okay, so if I want to have the probability of x equals to 1, then the formula will be 4c1, then 1 over 4 power 1, and then 3 over 4 power 3, right? Okay, then try to get the answer from the calculator, and you should get 27 over 64. Then if I want to get the probability for x equals to 2, then I will use 4c2. Again, I'm using the formula for binomial distribution. Okay, then 3 over 4 power 2. Then again, press calculator, you'll get the answer, which is 27 over 128. Alright, so this is by using the method of binomial distribution. If you successfully identify that it is a binomial distribution question. Okay, so you can fill in the value here, which is 27 over 64 and also 27 over 128. Okay, how about if let's say you are the one that not able to identify that this question belongs to binomial distribution. Alright, so if we're not able to identify, then we want to consider the probability of x equals to 1. We need to try to list out one possible case first. Okay, so for the first case, I have only one dice with number 2. Okay, in my out of the 4 dices, right? So the first case might be, first one is a 2, the second one is non-2, the third one is non-2, the fourth one is non-2. So if I write the probability here, 2 is 1 over 4, right? So I will write out 1 over 4 for the first dice. The second dice is non-2, so non-2 means 3 over 4. The third one, non-2, also 3 over 4. The fourth one, non-2, also 3 over 4. Okay, so these are the 4 possible probability for one case. First one is a 2, then the rest are non-2. But if I want to get only a 2 in all the 4 dices, right, this is not the only possible result, because we might have this case also. First one is non-2, second one is a 2, then the third one is non-2, fourth one is non-2. Then we have the third case also, where I'm having non-2, non-2, 2, and non-2. And again, the fourth case will be non-2, 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 and then I have a 2 here. Alright, so if you try to list out all the possible arrangement, right, you realize that they are having 4 different cases. Therefore, you can write as 4. Okay, or more accurately, I will want you to observe that originally I'm having 4 items, right? So to arrange the 4 items, it should be 4 factorial. Then out of the 4 items, I'm having 3 identical. So the 3 identical one will be all the non-2. So there are 3 identical. Therefore, I divide it by 3 factorial. And therefore, you have a 4. That's why the 4 actually comes from the idea that we're trying to arrange the 4 items where 3 of them are identical. Okay, to me, this is more accurate, alright? Of course, you can write multiply with 4, but the 4 actually comes from the number of permutation from the 4 items, alright? Okay, then again, when you try to calculate all the probability here, you should be able to get the same answer. So it should be 27 over 64. How about if I want to calculate the probability for x equals to 2? Okay, so for x equals to 2, again, I will have, maybe I assume first case, I'm having the first 2 dice which is a 2, and then the third and the fourth are not a 2, non-2. Alright, so if I want to list out the probability here, first one is a 2, that means it will be 1 over 4. Second one is also a 2, which is also 1 over 4. The third one is non-2, so 3 over 4. Fourth one is non-2, then 3 over 4. Okay, again, if you want to calculate all the possible cases, right, you need to try to list out all the possible cases here. Okay, but to me, this one might be slightly longer, right? Just now, all the other cases are quite short, only 4 cases, so you can list out very easily. But when you're having 2, 2, and 2 non-2, you can try to list out if you want, or if you have the idea how to do it. Okay, but for me, I think it is a waste of time, so I didn't show out in detail. So to calculate the arrangement for this one, I will try to involve the consideration of permutation. So I'm having 4 items here, right? So 4 factorial. And then divided by what? I'm having 2 identical items. Therefore, I want to divide it by 2 factorial. Another 2 identical items, so I want to divide it as 2 factorial as well. Alright, so 4 factorial divided by 2 factorial and 2 factorial, by right, you should get a 6. So if you want to list out, you can try to list out. Should be having 6 different arrangement. Alright, so for me, I'm writing out here 4 factorial, then divided by 2 factorial or 2 factorial. Again, if you want, you can try to list out all the possible 6 cases and you write it multiply with 6. Alright, okay. Then again, if you calculate the probability for this one, you should be able to get the same answer as well, which is 27 over 1 to 8. Alright, so this is how we solve the question for part number B. Okay, so there are 2 methods here. Of course, to me, I think this one will be more straightforward because from here I know that it's binomial and I can straight away apply the binomial formula. Alright, then now let's have a look for the next part, part C. Okay, so for part C, they want us to find the expected value of x. Okay, so just to recall back, what's the expected value for x formula? So basically it is the summation of x multiplied with the probability. Okay, or maybe you can, if you try to observe some other formula booklet or what, right? Maybe you can have a look straight away from our formula booklet. Where is the expected value formula? So we are having discrete random variable. So you can see expected value formula is summation of xp. So we straight away use this one, summation of xp. Okay, so I'm having summation xp, which means that you have to take the x multiplied with the p, then you add them together. Alright, so to find out the sum, ex, okay, so maybe you can refer back to your table. What's my x here? So the x is 0. The probability is 81 over 256. This is the first one. So in our step, I will try to write out 0 multiplied with 81 divided by 256. So the 0 is the x, then this one is the p, right? Then plus the next value. So what is the next value? 1 and 27 over 64. So I'm taking 1, then 27 over 64. So I do the same thing for the rest of the value x. So 2, 27 over 128. So 2, 27 over 128 and etc. Right? So you just try to observe the table and then you try to write out the formula. Then I'm having 3 over 64 and then 4. Then 1 over 256. Okay, then again, by just trying pressing the calculator, right, you'll get the expected value which is equals to 1. Okay, so this is by using the method, okay, where you don't know this is a binomial distribution, okay, or you can do it in the binomial way, where since I know that it is binomial distributed and I'm having 4 and also 1 over 4, right? Then to get the expected value from a binomial distribution, you can apply the formula straight away, which is n times p. So n is actually 4, p is 1 over 4, therefore you get the expected value which is equals to 1. So you can see that both methods give you the same value, give you the same answer. So it depends on which value actually you can see, I would say which method you can observe. All right, so these are the suggestion for you to get the answer for expected value for this question. Then let's continue further. Now he throws 4 dice the same time on 96 occasions. So that means every time I will throw 4 dice, and I'm throwing the 4 dice for 96 times. Okay, so that's the meaning. Right, so use an approximation, highlight the keyword approximation, to find the probability that he obtains at least 2s on fewer than 20 of these occasions. Okay, so maybe I want to focus on this one first, at least 2s. At least 2, not 2s, at least 2, which means that I want to focus on finding out the probability of the number of dice is 2, is at least 2, so that means greater equals to 2. Okay, the number of 2, the number of dice which is 2 is at least 2, more than equals to. Alright, so to calculate the probability for x greater equals to 2, again, you can straight away get the value from the table here. So what is the probability that x greater equals to 2? So this is x equals to 0, x equals to 1. So x greater equals to 2. That means I have to include this probability, x equals to 2, x equals to 3, and also x equals to 4. So I need to add all of them together. Alright, so if I add all of them together, I'm having 27 over 128 plus 3 over 64 plus 1 over 256. Alright, so you can straight away put in the value here. So 27 over 128. Then plus, what is the probability for x equals to 3? You're having 3 over 64. And then this one, 1 over 256. Okay, so by adding the 3 probability together, you get a probability of x greater equals to 2. So by right here, you should get 67 over 256. Alright, so for any single throw, the probability of we obtain at least 2 twos, right, will be this probability. And now I throw the 4 dice for 96 times. Therefore, I'm having another layer, another stage of binomial distribution where I'm having y. Y is the number of occasions. So total I'm having 96 occasions. And then the probability, the single probability of getting at least 2 in a throw is 67 over 256. Okay, and then since this question already hint us about the approximation. Alright, so for binomial distribution, we can actually change it become normal distribution. Alright, so for normal distribution, how can I get the mean for normal distribution? So you can take the mean for binomial, n times p. So when you take n times p, 96 multiplied with 67 over 256, you should get a fraction which is 201 over 8. Okay, so just to let you know, it is n times p lah. This is the n and this is the p. Okay, and then to get the variance, it will be np cubed. np cubed. So q means 1 minus p, right? So to get the value for np cubed, you take n times p times q again. So times q again, you get a long value. So for me, I will keep it as long as possible. Okay, because later when I apply the calculation with this value, right? Okay, I will want to keep it as long as possible so that I can get the most accurate answer. Okay, so after I change binomial become normal distribution, please take note that for binomial, it is a discrete random variable. Okay, then for normal distribution, it is a continuous random variable. So from discrete to continuous random variable, right? When you want to calculate the probability, you have to apply the continuity correction. Okay, so we'll start to calculate the probability now. Now they said fewer than 20 of this occasion. Fewer than 20. So the number of occasion is less than 20, no equal sign. Okay, and now I want to apply the continuity correction because from discrete to continuous, right? So I have to apply continuity correction. So the continuity correction for smaller than 20 should be 19.5. All right. And after that, since I know that it is now a normal distribution, so to calculate the probability, I need to change the y become z. So I have to standardize it. Right? So how to standardize it? I'm using 19.5, then minus the mean, minus 201 over 8, and then divide by standard deviation. So the standard deviation is square root. This one is a variance, right? So standard deviation should be square root of the variance. Okay, and after that, we try to find out the value of z correct to 3 decimal place. So the 3 decimal place will be negative 1.306. Okay, so correct to 3 decimal places because of when you want to find out the probability from the MF19, right? Okay, the maximum decimal place that we can consider is 3 decimal places. So that's why I find out until maximum decimal places here to get the most accurate answer. Alright, so z smaller than negative 1.306. If you try to observe it from a normal distribution table, okay, it should be this one, negative 1.306. And because of the sign smaller than, that means the area that I want to find out or the probability that I want to find out is this area, this part. But if you refer to the FF19, right, the normal distribution table, basically the value of z that they provide is only a positive z. They will not provide us with negative z. So we have to try to reflect it to the positive area, positive part, positive value of z, and then try to compare it. So that means the answer that I want to find, right, is the same as the green color here. Okay, and then to find out this green color probability, I need to take the normal distribution table. So I take 1, then minus, because for normal distribution table, they will give us the value that is smaller than the positive value of z. That means they will give us this whole area here, the big area. So to get the green color area, I have to take 1 minus the blue color area here, the big one. Okay, so I go to my table now, 1.306. So okay, let's have a look for the table. Look for the value of z. So this is the value of z here, right? 1.3. So this is 1.3. And they're asking for 1.306. So 1.30 is this one. So that means that if I want to look at the value, right, I should look at this value first, 1.30, which is 9032, and then look for the 6 at the back. So what's the 6 at the back? Okay, you will get a 10 here, right? That means for 9032, you have to add a 10 at the last 2 digits. So you're having 9042. Okay, so when you change it become probability, it will become 0.9042. Okay, so come back. I'm having the value 1 minus 0.9042. And from here, if I press calculator, answer should be 0.0958. Alright, so basically this is how we get the probability by using the normal distribution table. Alright. Okay, so we are now at the last question, question number 7. We have a children's wildlife magazine published every Monday, and then for the next 12 weeks, it will include a model animal as a free gift. Right, so for the coming 12 weeks only, we might have the model animal as a free gift, and then there are 5 different models here. So 5 different models. We have tiger, leopard, rhinoceros, elephant, and also buffalo, each with the same probability. So that means to get the probability of getting each type of model animal will be 1/5 because they are the same, right? They are having the same chance. We are having the same chance to getting each of them for being included in the magazine. Alright, so Sahim buys 1 copy of the magazine every Monday. Okay, so first question, they want us to find the probability that first time that the free gift is an elephant is before the 6th Monday. Okay, so highlight these 2 keywords here. First time that the elephant appear, okay, is before the 6th Monday. Keyword first time actually tell us the idea that it belongs to a geometric distribution. Because for geometric distribution, right, when you see the structure of the question, when you're having the first thing happen, first things happens up to and including a certain time, right? So that is actually a geometric distribution. Alright, so first time is a keyword that he knew that it is a geometric, and then now is before the 6th Monday. That means 6th Monday means that Sahib already buy maybe 5 magazine already, right? Before 6th Monday so not include the 6. That means he buy already 5 magazines, and then the the elephant appear before the 5 magazines that he buy. Alright, before the 6, that means before the 5. Okay, so when I write, it should be something like this. X is geometric distributed, and then the probability of getting the elephant is actually 1/5. And they are asking for the probability of getting the elephant, right, is before the 6th Monday. So not include the 6, so it should be smaller than 6. Okay, so when we want to calculate the probability for geometric distribution for x smaller than 6, right, that's a shortcut formula basically. What we have is, you can change it become x smaller equals to 5. Geometry is a discrete random variable. Therefore, the number of x must be usually integer. So x smaller than 6 means that x should be smaller or equals to 5. That means Sahim already might already buy 5 magazines. Okay, and then they're asking for the probability that the first elephant appear before or equals to the 5 magazines that he buy. So maybe he already get the first elephant in the first magazine, or maybe he get the first elephant in the 3rd magazine that he buy. Okay, so the maximum number is the 5th magazine he buy lah. Okay, the first elephant will appear. Alright, okay, so for x smaller equals to 5, okay, since we know that this is a geometric distribution, right, and there's a general formula for geometric distribution. When you want to find out x smaller equals to r, the general formula can be 1 minus q power r. Okay, this formula, I already checked just now. It is not provided in the formula booklet, but you can apply it if you can remember. Alright, so for this case, I'm having 1 minus, and then q means 4/5, 4/5, and then power r is a 5. Okay, so please take note that when you want to apply this formula, right, the symbol that you write must be x smaller equals to the r. That's why you can have a power r here. Okay, so for our example also the same. For our question, I rewrite my question become x smaller equals to 5, so that I can apply the power 5 in my calculation. And after that, I will get 2101 over 3125. Okay, or you can write it become 0.672 correct to 3 significant figure. Okay, so this is the first method when you know how to apply the formula for x smaller equals to r for a geometric distribution. Okay, if you're not able to remember this formula here, then you might have a longer step to calculate the probability for this question. Alright, so I'll write it here. Okay, so this is another alternative way. Alright, but of course it will be slightly longer because you didn't apply the formula. Okay, so again, I also know that it belongs to geometric distribution, and then the first elephant is 1/5. Okay, when they're asking for x smaller than 6, right? That means it cannot be x equals to 0. For geometric distribution, it must be at least start with x equals to 1, because you have to buy one magazine first, only you might get the free gift, right? So that means if Sahim is lucky, then he straight away get the first elephant in the first magazine that he buy. So it will be x equals to 1. Or maybe Sahim already buy 2 magazine. The first week magazine he didn't get an elephant, but the second week magazine he got an elephant. So in this case, it will be the probability of x equals to 2. That means he get the first elephant on the second Monday. Alright, so according to this definition here, if I continue to find out the probability, it can be also x equals to 3. That means when he buy the third magazine, only he get the first elephant. Then x equals to 4. When he buy the fourth magazine, then only he get the first elephant. And then when he buy the fifth magazine, then only he get the first elephant. Okay, then cannot be 6. Okay, because they said more before the 6th Monday. That means before he buy the 6th Monday, he already get the first elephant. So it can be first week get the elephant, second week only he get the elephant, the third one, the fourth one, and the fifth one. Okay, so for the probability of the first one, that means when he buy for the first time, he already get an elephant, right? So it will be 1/5. Okay, the probability of getting an elephant is 1/5. Then plus, if he get it on the second week of buying the magazine, right? That means first week he don't get the elephant, which is the probability 4/5. And the second week he get the magazine, so he get the elephant, therefore it will be 1/5. Okay, then if he get the elephant only on the third week, that means the first Monday he didn't get the elephant, 4/5. Second Monday he also didn't get the elephant, 4/5. Then the third one only he will get the elephant, which is 1/5. So the same thing apply for x equals to 4. So for x equals to 4, I'm having 4/5 power 3 and then 1/5. Apply the same concept, yeah. And then for x equals to 5, I'm having 4/5 power 4, then multiply with 1/5. Okay, so if you successfully list out, if you are patient enough, then of course you can straight away press the calculator and get the answer. So this is another way. Alright, so if you try to press the calculator and get the answer, right, the answer that you get should be the same like what you get just now. Okay, or maybe some students, they tend to list out the formula here and they will simplify it further. Okay, they feel like, okay, this one looks maybe a bit more complicated. So what they want to do is like, they might want to simplify it further, okay, to before get the answer. So at this step, if you want, you can straight away press the calculator and get the answer already. Alright, then if you want to simplify first, so some students say that, oh, I take out the 1/5 from all my terms here. If I take out 1/5, I will have the first term is a 1. Then the second part here, this one is 4/5. Then the third one will be 4/5 squared. And the next one is 4/5 power 3. And the last one is 4/5 power 4. Okay, so maybe you will actually observe, you can observe that this is a geometric progression. Geometric series, I will say. Geometric series. Okay, in pure maths that we learn. Alright, so we are trying to add the 1, 2, 3, 4, 5, the first 5 terms of a geometric series. So what's the formula here? Okay, so for this geometric series, the A is equals to 1 and the R is equals to 4/5. Okay, so if I want to calculate the first 5, the summation for the first 5 terms, right, for a geometric series, then what are we having is the formula A. Okay, so the sum of the first 5 terms will be what? It will be A. Then you can take 1 minus R power 5, then divided by 1 minus R. Okay, so if I substitute the value here, then I'll have A, which is a 1, then 1 minus R power 5. So multiply with 1 minus R power 5. R will be our 4/5. Then power 5 divided by 1 minus r, so 1 minus 4 over 5. And you realize that 1 over 5 and 1 minus 4 over 5 can be cancelled off. They are equal to each other. So our final answer, right, you can see that we actually get the summary of the formula that I showed you just now, which is 1 minus q power 5. And therefore you get the answer 0.672. Okay, but of course, if let's say you want to use this method, right, basically, it is just a longer method of applying the formula. 1 minus q power r. So you can see that the final step that I simplify all my equation here, right, I also get 1 minus q power r. So that's why you can actually straight away apply it. It is true for all the cases. Okay, just that if you don't want to simplify by using the geometric series, right, what you can do is straight away press the calculator when you successfully list out all the single cases here. Alright, of course the answer is still 0.672. So for this question, I show you both methods here is just to convince you that if you are having this kind of question in geometric distribution, you can straight away apply this particular formula where you're having 1 minus q power r. Okay, right, then this is what we have for part A. Let's continue to part number B. Okay, part number B, they want us to find the probability again. Probability that Sahim will get more than 2 leopards in the 12 magazines. Okay, so now we assume that we already get all the 12 magazines. Sahim already get all the 12 magazines. So you have a fixed number of magazine, right? So that means you're having a fixed number of n. So what's the fixed number of n here? Now it is binomial distributed. The fixed number of n is 12. And then we are interested to know how many leopards we get. So the probability of getting a leopard in one magazine is 1 over 5. Okay, so we're having a total of 12 magazines, and they said more than 2 magazines, something happened. More than 2 magazines, he get a leopard. So it is a binomial distribution when you're having this kind of structure of question. And then to set out the question here, they said more than 2 leopards, so x will be greater than 2. Okay, so to calculate this probability, you can get the probability of x equals to 3 plus x equals to 4 plus x equals to 5 and then x equals to 12, which is very, very long. So we want to do it the other way around, where I will want to take the total probability, which is a 1, then minus the cases that is less than or equals to 2. So that means I will want to take it minus 12c0, x equals to 0. So I'm having 1 over 5 power 0, then 4 over 5 power 12. Okay, then minus the probability of x equals to 1. So 12c1, 1 over 5 power 1, then 4 over 5 power 11. Okay, then I also want to minus the case 12c2. So 1 over 5 power 2, then 4 over 5 power 10. Okay, so from our equation here, we want to include 3 until 12. That means when I want to minus, I have to minus x equals to 0, x equals to 1, and also x equals to 2. Okay, so after I write out the formula here, then I straight away press calculator and try to get the answer. So if you didn't do any careless mistake, by right, your answer should be 0.442, correct to 3 significant figure. Okay, so this is how we solve part B. Alright, then how about we have a look for part C. Okay, so for part C, this question, they ask us find the probability again that the 5 weeks, after 5 weeks, Sahim has exactly one of each animal. Okay, so to calculate this probability, right, it doesn't belong to any single distribution. Because for 5 weeks, he's getting every single type of animal already. So that means, maybe I assume for week number 1, I get the leopard, so 1 over 5. Okay, the probability is 1 over 5, leopard. Then maybe for week number 2, I get an elephant, so 1 over 5, elephant. And then for week number 3, maybe he get the rhinoceros, so it's R. Then week number 4, what kind of animal he still have? Leopard, okay, go back to the question again. I can't remember. Alright, so you still have tiger and also buffalo. Okay, so maybe for 4th week I get a tiger, also 1 over 5, right? And then the last week I get buffalo, so B. Okay, so that means if let's say for 5 weeks I get exactly 1 of each animal, it will be 1 over 5 multiply 1 over 5 multiply 1 over 5 1 over 5 1 over 5. Okay, but this is for the cases where I'm having LERTB. That means first week I get leopard, second week I get elephant, third week I get this one, rhinoceros, the 4th week I get tiger, 5th week I get buffalo. But it can have other possible cases, right? Where maybe the first week you get elephant, then maybe the second week you get the rhinoceros, third week you get the buffalo, and so on. Therefore, besides listing out the probability here for this particular case, you also need to consider the possible arrangement for these 5 animals for 5 weeks. So to arrange these 5 animals for 5 weeks, we are having 5 different animals, right? Therefore, the arrangement will be multiply with 5 factorial. And all the animals here are not identical. Therefore, you no need to divide anything with factorial. So only consider the arrangement for 5 items, which is 5 factorial here. Then simplify this answer. You should be able to get 24 over 625. Okay, or if you want to correct it to decimal number, right? 3 significant figure will be 0.084. Okay, so this is how we actually answer this question. It is quite short actually, if you understand the concept clearly, that you need to involve the permutation of the 5 animals in the 5 weeks. Alright, okay, so here we ended our discussion for this paper. So thank you very much for watching this video.